Welcome to Armchair Physics. Today we're talking about bullets and satellites. This is my model of a satellite. Now, when a bullet comes out of the barrel of the gun, the barrel is designed so that the bullet is spinning. And this is for aerodynamic reasons. If it's not spinning, it's going to tend to have an erratic flight path. It's not going to go where you want it to. Now, a bullet spin really has to be along its longitudinal axis. You wouldn't have the bullet spinning like this. Obviously, that wouldn't work very well aerodynamically. So there's really only one choice for how a bullet spins to make it stable. Now, a satellite also spins, generally speaking, to make it stable, although for completely different reasons. The satellite isn't air. The reason you want the satellite spinning is because it will resist changes in direction, much like a bicycle is stable when it's moving because the wheels are spinning. So satellites generally spin, but a satellite is not a symmetrical object. It's kind of like this box, and so it's not obvious which axis you would choose for the spin. So you might choose to have the satellite spin like a bullet, you might choose to have it spin like a wheel, or you have the intermediate choice, the medium axis, where it spins like this. Now let's demonstrate these kinds of spins. So here's spinning like a wheel. Here's spinning like a bullet. And here's the intermediate axis. Whoa! You see that? At the end of the spin, it wasn't really spinning anymore. It was twisting and tumbling and doing all sorts of different things. So you can try this yourself with a DVD case or a book, although it kind of flaps around, or your cell phone if you're brave. But this is something well known, and we teach it in advanced physics classes. You can calculate that spinning around the longest axis is okay, spinning around the shortest axis is okay, but the intermediate one is no good. It's unstable. It will always start twisting around and tumbling. So this was, of course, known at the dawn of the space age, and so when people were designing the first satellites and thinking about how they would spin, they certainly didn't try to spin them about some intermediate axis. But whether you choose the longest one or the shortest one, that really would have seemed arbitrary. It wouldn't seem to matter. The math would suggest that as long as the object is really isolated from external influences, both are stable and it doesn't matter. Well, it turned out that when they launched the first American satellite, Explorer 1, didn't behave as they expected. The satellite looked kind of like a bullet, and they designed it to spin like a bullet. But when it got into space, it pretty quickly changed its direction, and ultimately it would tumble. And at the time, this was not understood. It was not what the math was telling them. And so they had to go back and really study the theory of rigid bodies, which hadn't been really seriously studied in a couple hundred years because it was fully understood, or so they thought, to figure out what was going on. It turns out that what happens is, well, the satellite isn't completely isolated from external influences when you're in space. If it were, it would be perfectly happy rotating either like a bullet or like a wheel. But it slowly loses energy and momentum and angular momentum, and these things that it couldn't lose if it were isolated. And it's a general principle in physics that although all these things are very well conserved when you're mostly isolated, it's much easier to exchange energy with your environment than it is momentum. Right? Think about being in the sun. The sun's going to heat you up very easily. You're going to get some energy, but it's not going to push you very far. It's much harder to get momentum from the sun. And the same is true from satellites. And so when they went and did the math again and sort of used the fact that energy could actually change very slowly, but angular momentum was pretty much conserved, they found that over long time scales, this kind of rotation tends to pick up a bit of this other rotation, which is unstable, and ultimately anything will tumble. So for satellites, you will never see a satellite spinning like a bullet. You will always see it spinning like a wheel.